So here we are at the end of Unit 6. We have talked about fossil fuels. We have talked about our conventional alternatives to fossil fuels. And now we're going to look at our new renewable energy sources. Okay, so we're going to look at the major sources of renewable energy and look at how they've grown recently and what they could grow to be in the future. We're going to look at solar, wind, geothermal, and ocean as potential new alternative energy sources. And we're also going to look at hydrogen fuel cells as a way to store future energy for future use. So if we look at the conventional alternatives that we looked at in the last chapter that are renewable, which are hydropower and biomass, it's great that they're renewable, but they are only renewable if we're careful about our use. So we want to look at other methods that we can use that are perpetually renewable. We don't have to be as careful with their use. So the ones we can look at are energy from the sun, wind, geothermal heat, which is heat from the earth, we'll talk about that, and ocean water. They're considered new renewables because they're really up and coming. They're just starting to be used on a wide scale. There's a lot of technology development in these areas, and they're probably going to make a much bigger role in future electricity generation in particular as time passes and that technology develops. They're growing quickly. Okay, so we have two diagrams here. U.S. consumption of renewable energy by source. So all of the energy that we use, right, here are the renewables, most of it's bioenergy, then hydropower, then wind, solar, and geothermal. So all of our renewable energy, most of it is bioenergy. If we look at electricity generation, just electricity generation from renewable resources, most of our electricity is generated using hydropower, okay? About a third of it, of this 17.7%, which really isn't a lot. Followed by wind, solar, bioenergy, and geothermal, okay? So they make up a small portion of our overall energy budget, but is growing quickly. So what are the perks of these new renewables? We reduce air pollution, we reduce greenhouse gas emissions that drive global climate change, and it diversifies an economy's energy mix. Instead of just being reliant on fossil fuels from foreign countries, we can generate, we can have our own sources of energy homegrown. Okay, so it reduces a lot of that reliance on foreign countries. All right, shifting to renewable energy creates a lot of employment opportunities, from engineers who have to design the technology to people who have to install the technology, like this guy here, to people who have to maintain it. So these jobs are called green-collar jobs. 20 years ago, 20 or more years ago, when I started teaching, green-collar jobs didn't exist. Okay, so this is one of those things that is a perk to moving towards these new renewable energy sources. In order for it to happen, we need policy. Okay, we need the subsidies, to be removed from the fossil fuel industry, and the demand to go up for these renewable sources. Okay, it's more expensive, mostly because of those subsidies. Okay, we can create policy that supports it, right? So you could set goals or mandates set by governments. Governments can set these to mandate that a minimum amount of power that supports the grid comes from renewable sources. Governments can invest in research and development. Governments and banks can lend money to these businesses that are looking to create renewable energy sources. And you can provide tax credits and rebates to individuals that buy renewable energy. They buy their electricity from a source that's known to be renewable, or they have their own. They produce their own with solar panels or windmills or whatnot. Okay, so the subsidies, right? The tax breaks and the money that have gone into nuclear and fossil fuels over the course of time are much, much higher than what renewables have seen. Okay, so oil and gas have received 75 times more subsidies over the course of their existence as a power source. And nuclear power has received 31 more times more subsidies than renewable energy. So the government is keeping the cost of these sources low intentionally. Okay, so we need some of those subsidies to leave nuclear and oil and gas and go to these new renewables, which will then shift the balance. Per year, oil and gas have received 13 times more subsidies, and nuclear power has received 9 times more subsidies per year, okay, than renewable energy. Okay, so it's ridiculous. So this is why we are still in the oil and gas and nuclear era. All right, and oil and wind, solar, and geothermal have only 1 year ever received as much support as the lowest amount ever offered to oil, gas, and nuclear. Okay, so there is governmental pressure. Okay, there's government money to keep oil, gas, and nuclear cheap, and that doesn't happen with our renewables. All right, so that's kind of like why we've been so hooked on non-renewables for a very long time. In order for that to change, thinking has to change. All right, so let's talk about these new renewables. So solar energy, Captain Obvious, is energy from the sun. Every day, the Earth receives enough solar energy to power human consumption at the current rate for 25 years. Every day. Okay, so we have a century in less than a week. Okay, so there's a lot of potential there. The challenge of solar is finding cost-effective ways to collect it and then convert it to energy. All right, so there's 2 different ways that we can collect solar energy, right? One is passive solar energy collection. Passive, if you're sitting there passively, you're just kind of listening. You're not like actively engaged. Your brain is not, rolling. You're just kind of sitting there, right? So in this case, it's passive solar energy is utilized through design, right? So you design buildings to maximize the absorption of sunlight in the winter while doing what you can in the summer to keep the building cool, all right? So some examples. You can put plants around the house to allow them to be a buffer for big temperature swings. You can build your porch facing south, so that way when the low angle light comes in the winter, that part of the house gets warm. You can put you can increase the insulation in your house to swing against temperature shifts. You can put in special glass that allows higher angle sun in the summer to get reflected, but lower angle sun in the winter to penetrate through. You can design materials, right, to absorb the heat. They're called thermal mass materials, right? So they'll absorb the heat and then they'll store it and then they'll re-radiate it slowly for times when you need heat in like the nighttime or in the winter. Okay, so passive, there's no extra equipment necessary. It's all in your design and the choice of your materials. Active solar energy collection uses equipment, okay? So this is a solar water heater. You can use devices or equipment on the roof, in your backyard, wherever, to focus, move, or store solar energy. So that's how this hot water heater works. Okay, it collects the rays of the sun and then it runs through, okay, to heat the water to go to the boiler, to the hot water tank. That is a hot water tank, to go to your hot water tap. Okay, so that's one way, this flat panel water heater. You can use concentrated solar power, like a solar cooker, like this in India. Use reflectors to focus that sunlight and to cook food. You can make, my daughter in her gifted and talented class made s'mores that way in a solar oven. They roasted the marshmallows in the solar oven and then ate them on s'mores. Okay. Other ways, you can use this parabolic trough to focus the sun's energy to heat the liquid in these tubes, which will then go on to create steam to turn a turbine to generate electricity. There are also curved mirrors, right? In each case, you've got a movement of the rays to focus solar power. And there's an example of one of them in Spain. All of the solar radiation makes its way to the concentration tower, and then they drive generators. Okay. Another method, this is one of our most common methods, the ones you tend to see around here, for active solar energy is the use of photovoltaic or PV cells, right? So you've got the sunlight, you've got the array. In each array is a photovoltaic cell, okay? It gets energized by the sunlight. Electrons moving electrons generates electricity. Okay, so that's how our solar field works. All right. In order for it to really work, if you have a photovoltaic cell like on your house, you must be able to either store that excess energy, right? So batteries, to use when you don't have enough solar load to generate electricity, or they wind up selling it back to the local power company. You hear a lot about people's meters running backwards. So that's this idea of net metering. The value of the power the consumer provides is subtracted from the consumer's monthly utility bill. If their electricity meter runs backwards, that means they're putting power into the grid rather than pulling power from the grid. So for the investment, some people really enjoy having their meter running backwards. So it's got a lot of benefits. It's inexhaustible. Solar power is inexhaustible. The sun probably won't go red giant for about 5 billion years. So it's definitely within a human lifetime to be able to utilize solar power. There's enough solar energy hitting the earth to power the civilization. Once we figure out how to use it, you don't need fuel, there are no moving parts, you get a whole lot of green jobs, and there are no greenhouse gases. So it sounds really great. But there are drawbacks, okay? Again, cost-benefit analysis. Not all regions in the world are equally sunny. You know, at the poles, the North Pole and the South Pole, above 60 degrees latitude, either way, the sun will set in December, and it really won't come back up again until like June, maybe March, okay? So there's a lot of darkness up there. Solar energy is not going to work really well up there, right? In the Southwest, in the United States, and down in Florida, they get a lot more sunlight. There's Alaska right there. They get a lot more sunlight, so it's going to work well there. Here we get a decent amount of sunlight, not a whole lot, not, more than what they get in central and northern Germany, more than what they get in Alaska, okay? So it's not as useful everywhere, okay? It's also intermittent, okay? So that means that there are daily variations or seasonal variations that may not allow customers or people with solar to have a consistent energy supply without some means of storage, some batteries. And it's also expensive to purchase and install. But within 10 years of use, it'll pay for itself. That's a long time for some people. It's really not in the scope of home ownership. But it's expanding. It's expanding tremendously. okay? It's grown a third each year over the past 4 decades, and China is typically the leader in solar technology. So it's working so quickly. China is moving so quickly to drive. Then the U.S. manufacturers can't keep up. So there's the price. Price has dropped tremendously, and production has gone up tremendously in that way. All right, second kind of wind. Second kind of new alternative is wind. Wind happens from the differentially heated air masses. So wind moves from high pressure to low pressure, right? So where air is generally cooler to where air is generally warmer. And we've developed these things called wind turbines that you can see here to convert that mechanical energy of wind into electrical energy. So the blade spins, which makes the gearbox spin, which spins the generator, which generates electricity, right? So the blades turn the rotor, and the rotor is inside something called a nacelle. All right. The nacelle is kind of cool because this nacelle, winds generally come from a prevailing direction, but that nacelle will move on top of the tower, okay? It's designed to yaw is the word, or it rotates back and forth. It kind of like shakes its head side to side. So it makes sure that that motor is facing into the wind at all times. There's a direct connection between the speed of the wind and the electricity generation. If you double wind velocity, you get 8 times the output, power output. So that's definitely a great return on your investment. And they set up turbines in groups, and they call that a wind farm. It's growing really fast, okay? It's going up very, very quickly in China, in the US, and in Germany. Denmark, Ireland, and Portugal lead the way in wind, but we are coming. We're definitely above the world average, which is good. Offshore wind farms are kind of ideal. The initial costs are high because you have to get all of that equipment out into the ocean, but they have higher energy production potential over time. So when air moves over land, because land is not flat, okay, different areas of land receive more radiation than others, so it makes the air move differently. That inconsistent movement of air we call turbulence, right? It's rough air. Air masses of different temperatures bump into each other and they create turbulence, like when you're on an airplane. When you're over the water, because water has such a high heat capacity, the temperature tends to stay stable, so the air over it will maintain the temperature, okay? So it creates less turbulence, so you have greater wind speed. And the greater the speed of the wind, the greater the potential for wind power. It's pretty easy. You know, it's got a lot of benefits, right? The things you prevent the release of carbon dioxide, sulfur dioxide, NOxes, and a whole lot of mercury, all of which contribute to air pollution, as we talked about in the previous unit. They produce 20 times more energy than they consume, which makes for a great EROI. And you can always add more turbines, right? It's easier to add more turbines. Okay? It's an intermittent source, so there are places that are really good for it, the Great Plains and the coast. So geography is really what determines how much wind power is available. You need flat, open areas with less turbulence to really have good wind power, which is why they're doing a lot off the coast. A lot of people, because people live on the coast, if you're going to put a lot of wind power in the Great Plains, you need infrastructure to move that energy from where it's generated to where it's needed, which is why a lot of people That's why a lot of companies are investing and looking into doing coastal offshore wind farms. If you do them near a population center, you come up with something that local residents have issues with. They don't want it in their backyard. So it's the idea of NIMBY, not in my backyard. Just like nobody wanted nobody wants fracking in their backyard. Nobody wants a nuclear power plant in their backyard. The residents around Yucca Mountain in Nevada didn't want a nuclear waste dump in their backyard. So that's a big push for aesthetic reasons. They don't want that kind of stuff in their area. So that's the idea of NIMBY, not in my backyard. And turbines can also pose a threat to birds and bats. If they fly into the rotating blades, they can die. One study suggests that if you paint one of the blades black, it breaks up the visual of the rotating blades, so those deaths by collision are less likely. All right, third one is geothermal. It's energy from within the Earth's surface. Geo is Earth and thermal is heat, okay? It manifests itself at the surface in certain areas, right? So there are areas where convection in the asthenosphere, which we're going to talk about in the next unit, brings magma material closer to the surface. So you have these hot spots under the surface, okay? We are not in one of those hot spots. The Earth itself is kind of chilly underneath our crust. So what can you do? You can drill wells down into heated groundwater. Then that can come up to provide heat for the buildings. That steam comes up to turn a turbine to generate electricity. You can place power plants in those areas and then set up the system of wires and stuff to distribute that energy. So the steam will come up into the power plant, which will turn the turbine, which will generate the electricity. They use it a lot in Iceland because Iceland is the mid-ocean ridge at the surface. There's quite a bit of magma below the surface, so they use geothermal heat all the time, and they can transport it pretty much across various parts of the country. So if you go down into the ground, you wind up seeing that temperature changes a lot more slowly below the ground because soil tends to release heat more slowly. So the earth, the deeper into the earth you go in the crust, it tends to be isolated and insulated from temperature changes. There are these things called ground source heat pumps that take advantage of that fact. They transfer heat from the ground up to the buildings in the winter when air temperature is cooler than that temperature, and then they do the opposite. They take heat from the surface and put it down into the earth during the summer to allow cooling to take place. They're pretty energy efficient because energy is just moving inside to outside, from place to place, instead of being produced from these outside inputs. Downsides to geothermal energy, it can release dissolved gases such as carbon dioxide, methane, ammonia, and hydrogen sulfide, which are known to cause human health issues or air pollution issues, but they're at much smaller levels than what you would see by burning fossil fuels. Geothermal is renewable, but if you're not careful with how fast you use it, you can use that heated water faster. You can pull it up faster than it's recharged naturally. And this is the thing that I'm completely aware of as a trained geologist. The Earth's crust shifts naturally over time, okay? So there are natural changes that happen in the asthenosphere that impact changes in the lithosphere, which means that just because an area has is a good source of geothermal power now, it might not be that way in a human lifetime, certainly not in over the course of geologic time. So this is kind of cool. We can use wave energy, okay? Just like in hydroelectric power, you can put these energy converters out into the ocean. The oceans are always moving, right? Not only in terms of tides, but in terms of ocean waves. You can use that to generate electricity. It floats up and down with the waves. And here's how that would work. It's greatest in the open ocean. So to set these things up in the open ocean would be ideal. But again, people generally don't live in the open ocean. They live on the coasts or inland. So you have to get that energy from where it's generated to where it can be used. And that's definitely not cheap. So if you live in a coastal area, you can do one of two things. You can funnel waves from a large area into a narrower channel and an elevated reservoir, which then flows water through a turbine, which turns the generator, which creates electricity. Or you can use rising falling waves to push air in and out of chambers, which then spins the turbine, which makes it generate electricity. Areas with a big difference in the tides, like here in South Korea, can use tidal energy. So as the tides rise and fall, that change in water level can turn the turbine to generate electricity. So if we're going to generate all of this electricity, we're going to use all of these alternative energy sources, we want to have a spot to put it. So when you have a neap tide, when there isn't a whole bunch of difference between high tide and low tide, or in areas where you don't have a large tidal range, you need to be able to store that energy that's generated when you do have access to it. It's really hard to do for cheaply in large quantities. So batteries are the things that tend to do it. We know what kinds of batteries they have. You've lived in the world. Disposable batteries, rechargeable lead acid batteries, and rechargeable lithium ion batteries. Most of our cell phones are rechargeable, and our electric cars are rechargeable lithium ion batteries. Okay, there's a wind project in Texas that has a whole lot of storage power for a power plant. So if we're going to store energy somehow, this is a good way, good alternative to batteries. So the idea is for a fuel cell. Okay, so a fuel cell uses hydrogen as a stored power source. They put hydrogen essentially in a canister. Okay, hydrogen is actually pretty easy to generate. You basically put a little electricity through water under the right conditions of pressure and temperature, and it splits into hydrogen and oxygen. That's called hydrolysis, right? Lysis is the breaking, hydro is water. So it's the breaking of water. So you create hydrogen and you put it in these fuel canisters, and then when you combine it with oxygen, that energy gets released, okay? So what comes out is water. And this is the way the hydrogen fuel cells work. It is really a big push to have hydrogen fuel cell vehicles, right? So a lot of cities have been converting their buses to run on hydrogen fuel cells. It doesn't produce any pollution, right? Literally what comes out of the tailpipe is water. So transitioning from gas and fossil fuels to hydrogen could really reduce reliance on foreign fuels. And it's going to reduce greenhouse emissions that lead to climate change. This is key, as is the case with all of these alternative energy sources like electric cars. The cleanliness of hydrogen depends on how you get the hydrogen. What do you use? What power source do you use to do hydrolysis? If it's fossil fuels, it is not going to be as clean as if you use like solar. It can come out of other molecules like methane. It's going to be cheaper, but there's a greater chance of pollution. We are never going to run out of hydrogen because it is the most abundant element in the universe, okay? And they're really efficient, Okay, between 35 and 70% of the energy that's released in the reaction gets used to move the vehicle down the line. It's only like 16% in an internal combustion engine. So it's a lot more efficient. Here's the challenge, okay? We have in the United States a series of gas stations. Like if your internal combustion engine vehicle is running low on gas, you find a gas station and you fill up. We're getting to the point where we have charging stations for electric cars. But here's the problem. Converting a nation's infrastructure to hydrogen, right? So turning all of our cars into hydrogen fuel cell vehicles would require a huge and expensive change in our infrastructure. We would need to have hydrogen fueling stations, and that's a priority in California. We'll talk about that in our key points. But it's not really a priority anywhere else. You could also have some leakage of hydrogen that will deplete stratospheric ozone and increase the residence time for methane. So there are downsides to it. It's not a perfect solution. Okay, so that ends our discussion of Unit 6, Energy Sources and Energy Resources and Consumption.